Now let's try to solve last question of this chapter, question number 64, which says that there is a smooth sphere of radius r, right? So this sphere has a radius r and it is smooth. That means there is no friction. Made to translate in a straight line with a constant acceleration a. That means this sphere is, let's say, it is made to translate in the left direction with the acceleration a. A particle kept on top of the sphere and is released from there at a zero velocity with respect to, that means there was a particle here which is released. Now, obviously, if this particle is released, this will move in this direction because the sphere is being pulled in left direction. It will move in the right side direction. Then the question is, find the speed of the particle. Respect to the sphere, with respect to the sphere, because sphere itself has a speed, do not consider that. With respect to the sphere, what is the speed of this particle? As a function of angle theta as it slides. So let us draw the free body diagram. Let us say this is where the body lies at this moment. And this angle is theta, right? Now, if you imagine, you have to imagine the forces acting on this body. What are the forces acting on this body? One force is always present, the force mg, and this force mg has a tangential component which is m sine theta, right? Which is mg sine theta. This we have seen right from the beginning of this chapter. This force is mg sine theta. Now, when the particular catch of this problem is the sphere itself is moving with an acceleration. Is the sphere moving with the acceleration towards left, then this body, which is on the sphere, is also moving to the left along with the sphere. And if it is moving to the left, then in absolute consideration, this has got there is a leftward force applied on it, which is equal to ma, mass into acceleration. And so there is a reaction on the body also, which is equal to ma. Without this reaction, the body will get detached from the sphere. This is the actual argument. Ma is a force. This also has a component in this direction, which is ma, which is ma cos theta. So what are the forces in the tangential direction? Mg cos theta and ma cos theta. And what mg cos theta and ma cos theta produces? Let us write here. Mg cos theta plus NA cos theta. These are the causes. And what is the result of this cause? Result of this cause is it produces, for the sake of brevity, I draw it here. It produces a tangential acceleration, which is equal to dv dt. This force is equal to actually m dv dt. So we should write this is a force equal to m dv dt. Let us write down what is v. V is equal to tangential velocity. Tangential velocity, that means dv dt is tangential acceleration, multiplied by mass is the tangential force. And who supplies that force? Mg sin theta and Ma cos theta. They together supplies the force. And this is, you consider this one equation. Another thing, let us not forget, this V is also equal to R theta dt, where theta is the angle measured in radian. Right? So putting this value of V, what we get here? So we get m dv dt. So we get m dv dt is equal to m dv dt is equal to, let us, it is actually, I was going to write the same equation once again. Let's avoid that. We multiply both left hand side and right hand side with v first. Then what do we get? M v dt is equal to m a v plus m g v sin theta. So from here we get this second equation by multiplying both left hand side and right hand side with v. From here we get, now we can also cancel m's. All m's you can cancel. From here we get v dv dt, v t is equal to a. And what is v? This v is r d theta dt. So we write r dt multiplied by cos theta plus m got cancelled, g, v is again r d theta dt sin theta into sin theta. Now all these dt's and the numerator you can ignore. Then it becomes dv is equal to a R cos theta d theta plus G R sin theta d theta. Why we did this? We wanted to really bring equation on theta, right? Now, if you integrate both sides, we write integrate both sides, then we get v square upon 2, because left side is an integration on dv, right side is an integration of theta, is equal to AR. Integration of cos theta is sin theta, minus integration of sin theta is minus cos theta. So minus GR cos theta plus there is a constant C. We write here C is equal to a. Now, how do you find out the value of C? When theta was 0, the tangential velocity V was 0 because it just started from here. So we write at the start, theta was equal to 0 and V was equal to 0. So we rewrite the equation now. This is equal to 0, 0 equal to sine theta is 0, sine 0, 0 minus cos 0 is 1. So GR plus C. From here we find C equal to P. That is so. Then putting the value of C in the main equation, what we find? V square by 2 is equal to AR sin theta, AR sin theta minus GR cos theta, and C is equal to GR plus GR. From here we get square is equal to 2 will come on the right hand side, and we take R common because there is R in all the three terms. V square is equal to 2R multiplied by A sin theta, A sin theta plus G minus R is taken common, so G cos theta. This is V square. If this is V square, so V is equal to whole under root 2R A sin theta plus G minus G. Now, this completes this chapter of work energy power. But I am inclined to make a comment from myself, because I have seen that in this textbook, at the end of every chapter, there are some numerical problems based on too much of theoretical calculation. I have a feeling that those who are preparing for competitive examinations should rather try such problem sums which are more inclined towards applied physics. That is all my personal feeling. So it's up to you how you do it. Okay, so this finishes this chapter. I hope some students are getting benefited. Even if one student gets benefited, I'll be very, very thankful. And I would always invite comments in the comment section if you have any doubt anywhere. And actually, I have omitted such problem sums which, in my observations, is easy and any average student will be able to solve it. But still, if you find there is some problem where you need help, please write in the comment section. That gives me some kind of encouragement. And uh, last but not the least, if you can subscribe to the channel or you can share this channel with your schoolmates or classmates, I shall be extremely grateful to you. Okay. Next time we shall go to the next chapter.